haloalkanes. So this is where your hydrocarbon has at least one halogen on it. So at least one halogen. Now when you're naming them, find the longest carbon, the longest continuous carbon chain containing the halogen, and this is the parent chain or the root part of the name. So then you've got to identify the halogens present. If there's more than one halogen present, you're going to list them in alphabetical order. And the one that comes alphabetically first gets priority in terms of numbering. So you number from the first alphabetical halogen. So priority for numbering is with the first alphabetically. And again, of course, you want the lowest possible numbers when labeling. Any side groups, identify, and number accordingly. Okay, let's take a look at this first structure. So we have a halogen here and a halogen here. They're the same. So this one will be straightforward. And our longest carbon chain that has these halogens is 3. So propane is our root. It's ane because they're all single bonds, so it's an alkane. And then we've got 2 chlorine groups. So the prefix is chloro. Because there's 2, it's dichloro. And we have to indicate with a number each chlorine. So even though they're on the same one, we have to put a number for each chlorine group. So this is 1, 1 hyphen dichloropropane. So this tells us that there's 2 chlorine groups on carbon number 1 of a 3-carbon alkane. Now, if we look at the next diagram, we have 2 halogens. We've got a bromine and we've got a chlorine. So bromine is alphabetically first, so it's going to take priority. And our longest carbon, continuous carbon chain is 5. So it's a pentane. They're all single bonds. So our root is pentane. And we have a bromo and a chloro as a side group. Because numbering priority goes alphabetically here, we're going to start numbering from the left because that will give us our lowest possible combination. If it went from the other end, it would be carbons 3 and 4. This way it's carbons 2 and 3. So bromine is on carbon 2, and the bromine is on carbon 3. So it's 2 bromo, 3 chloro, pentane. Now if we take a look at the last structure here, we have a halogen side group. Our longest continuous chain is either 4 or 4. Either way, numbering here, there will be a methyl group on carbon number 3. So let's get to it. We have a chlorine group on the second carbon, counting from this end, so that has priority. Now the other side group is a methyl group. So chloro comes alphabetically before methyl. So this is 2 chloro, 3 methyl, and then the longest carbon chain is butane. So drawing haloalkanes, identify the root from the name. So that's your longest carbon chain. So link the carbon chain. Number them. Identify your prefixes, your chloro, your bromo, etc., and any other side group. So side groups are included here. Includes all your side groups. And then they're identified by their numbers in the name. So place accordingly. Let's draw this compound. 2 bromo, 5 chloro, 4 ethyl, nonane. So the root is nonane. So that means 9 carbons. So we have to draw out 9 carbons. 5, 6, 7, 8, 9. Put in your bonds. Now we're going to fill in your side groups. So the bromine group is on carbon number 2. Number 5 has a chlorine. And then there's an ethyl group on carbon number 4. So a CH2CH3 group. And we're going to fill the rest of the bonds in with hydrogens. There's a lot of hydrogens. So, carbon 1, 2, bromo, 3, 4, ethyl, 5, chloro, 6, 7, 8, 9, nonane. So there's your structure. Okay, physical properties of the haloalkanes. So, the haloalkanes are polar because they have a carbon with a halogen, so that's a polar covalent bond. So they have London dispersion forces and dipole-dipole. So as a result of these intermolecular forces, their boiling points are higher than their alkanes of the same carbon length, because you need more energy to overcome those attractive forces that they have for each other. So the boiling points are higher. Only the halomethanes are soluble in water, and that's because they're so small. Everything else is insoluble.